Good day, students. On this clip, we're going to be going over uh, how to solve radical equations. So let's write on the title for this notes: solving radical equations. Okay. All right. Now let's take a look at some examples. All right. So number one, solve x equals the square root of x plus 7, the whole quantity plus 5. Okay, so in order to solve an absolute value, a radical equation, you get the radicals on one side, square to eliminate, and then you proceed. Okay, so I want to get this radical. I want to get it on one side. This radical right here. My goal is to isolate this radical. Okay, so this radical can be isolated. I'll square both sides, and then I'll get rid of it. Okay, so let's do that. So what I'm going to do is I'm going to subtract 5 from both sides to isolate the radical. So I'm going to have x minus 5 equals the square root of x plus 7. Now, to get rid of this radical, I'm going to square both sides. So I'll square the left side, and I'll square the right side. Okay? Now, there's a formula for squaring binomials that will be really helpful in this section. The formula is as follows. The formula is a, there are two of them. There's a plus 1, write this in red. A, now let's do the minus 1 here. A minus b squared is equal to a squared minus 2ab plus b squared. Alright, if you add the square of any binomial, the sum of difference, this is the formula you use. Okay, so let's do that for here. So in this case, this right here is my a, and this is my b. So I'm going to apply this formula. Watch this carefully. This is going to become x squared, which is equivalent to a squared, minus 2ab, 2, a is x, b is 5. Do not take the signs, please. Do not take the signs because you're going to ruin the whole problem, okay? Plus b squared, which is 5 squared. That's the left side. On the right side, the square and the square roots cancel out. So we're going to have equals x plus 7. To simplify further, we're going to have x squared minus 10x plus 25 equals x plus 7. Now, this is a quadratic. In order to solve this, we need to put it in standard form, namely make it equal to 0, okay? So I will subtract x from both sides and subtract 7 from both sides so I can have it equal to 0, okay? So subtract x and subtract 7. That yields x squared minus 11x plus 18 equals 0, all right? So how do we solve this? We use the x game or the quadratic formula or completing the square or by graphing. So let's try the x game since that's the quickest method. So hopefully this is factorable and then the x game would work. So AC goes on top, B goes on the bottom. AC on top, B goes on the bottom. Alright, so in this problem, what is AC? AC is 1, let's say A is 1 and C is 18. 1 times 18 is 18. And then b is negative 11. So what two numbers times to give you 18 and add to give you 11? Negative 9, negative 2. Works perfectly here. So let's put that in the center. So we're going to have x squared minus 9x minus 2x plus 18 equals 0. Alright? Break it down in the center and factor by grouping. From the first two, I'll factor out x, and we're left with x minus 9. From the next two, I'll take out negative 2, and I'm left with x minus 9. This is good because these two quantities are the same, so it's going to factor into x minus 9 times x minus 2 equals 0. Now, to apply the zero product property, what we're going to do is we're going to set each factor to 0. So we're going to have x minus 9 equals 0, and x minus 2 equals 0. To solve this, the left side, you add 9 to both sides. X equals 9. That's the first possible solution. And then this one, you add 2 to both sides. X equals 2 is our next possible solution. So since we see the square in here, we might have introduced some foreign bodies or some unwanted elements into our problem, or some shoes into our net. So we need to find which of these are extraneous. These two could be extraneous, or one of them could be extraneous, or both of them could be actually real solutions. So we must do a check. Okay? So now we're going to do a check. Right now, check. The original problem was x equals the square root of x plus 7 plus 5. So we're going to test x equals 9 first. Okay? So let's test that one. X equals 9. The question is 9 equals the square root of x plus now equals the square root of 9 plus 7 plus 5? Is it? Is 9 equals the square root of 16 plus 5? As 9 equals 4 plus 5. 9 is definitely equal to 9. So this answer is good. It's a real answer. Alright? Next, we're going to test x equals 2 to see if it's an extraneous solution or not. X equals 2. The question is, plugging 2 into the original question. Is 2 equals the square root of 2 plus 7 plus 5? Is 2 equals the square root of 9 plus 5? Is 2 equals 3 plus 5? The question is 2 equals 8? Absolutely not. So this is like the shoe, or this is not a solution. This is extraneous. So this one right here is extraneous. Okay? It's not a valid solution. So our solution is x equals 9 because it passed the test. Okay, so x equals 9 is our answer. Alright, now let's move on to another example. Let's take a look at the following scenario. Example 2. Solve the cube root of t minus 2 equals 2. Let's solve that. So to solve that, first of all, what's the opposite of cube? The opposite of cube is cube root, or the opposite of the third root is the third power, right? So what I'm going to do is, to get rid of the third root, I'm going to raise both sides to the third power. So the left side to the third power, and the right side to the third power. Why? Because the opposite of cube root is cube. Alright, so these two are opposite or inverse operations, so they cancel out. So I'm left with t minus 2 equals 8. You add 2 to both sides, and then you have t equals 10. Okay? The other extraneous solutions introduced here is only when you raise it to an even power, that's when you have a possibility of having an extraneous solution. But let's just check though, just to make sure our answer is correct. So let's do a real quick check. The question is the cube root of 10 minus 2 equals 2? Is that the case? Is the cube root of 8 equals 2? The cube root of 8 is definitely 2. Is 2 equal to 2? Yes. So our answer is correct. T equals 10. Alright, so that's how you solve a situation like this. Alright, now let's try another example. This one was a little bit more intense, so I'll need you to pay real close attention. Example number 3, solve the square root of x plus 10 equals 5 minus the square root of 3 minus x. So in this case, you basically want to isolate the radicals, square them to get rid of them. If a radical shows up, you do the same thing again. Alright? So we have two radicals here. Let's put them on the same side. So I'm going to take this whole term and move it to the left side. So I'm going to have the square root of x plus 10. Oh wait, how do I have that happen? I need to add the square root of 3 minus x to both sides, right? Add the square root of 3 minus x to both sides. So I'm going to have the square root of 10 plus x plus the square root of 3 minus x equals 5. Okay? Now to get rid of the square root, what I'm going to do is I'm going to square both sides, okay? So um, on so I'm going to square this side. Or wait a minute. Yeah, so this one's squared, and then this one's squared. All right. So how do I square this monstrosity over here? Let's use that formula I showed you before. The formula is a square. Oh no, the formula is a plus b square. So a plus b square is what? A square plus 2ab plus b square. All right. So that's the formula we're going to apply here. Okay, so to do this, note that this whole business right here, this is A. This is A and this is B. Okay, square root of x plus 10 is A, square root of 3 minus x is B. So if I do A square, this is going to become the square root of x plus 10 square. This is A, x plus 10 square, plus 2ab, A is the square root of x plus 10, and B is the square root of 3 minus x, AB plus b square, which is the square root of 3 minus x square. On the right side, 5 square is simply 25. Okay? When we simplify this, we're going to end up with x plus 10, because the square and the square roots cancel out, plus 2. Now, all we just simply need to do is we can just follow these two together since they're going to be combined. So x plus 3, you just follow this out. Well, let me rewrite it. So it's going to be x plus 10. Well, let's do it on the side in order to save time. So on the side, we're going to do x plus 10 times 3 minus x, because these two are going to be combined, right? So if I combine them, I'm going to have, just follow it out, you're going to have 3x minus x squared plus 10x, and then plus 30 minus 10x. All right, let's do that again. 3x minus x squared plus 30 minus 10x. And write in standard form is negative x squared minus 7x plus 30. So that's it in standard form. So inside the square roots, following these two is going to give us negative x squared minus 7x plus 30 plus, on the right side, 3 minus x equals 25. So there goes the next simplified step. Okay, so now what I want to do is I want to isolate this radical. You see this radical right here? I want to isolate it, this radical business. I want to isolate it so that I can eliminate it by squaring. Okay, so I need to isolate this radical component right here, this radical. Okay, so how do I do that? I need to move everything to the other side. Oh wait, this is equal 25. So move everything to this side. So let's simplify first before I start moving stuff over. On the left side, I can combine x and x. X minus x cancels out, so those two cancel out. Right? And then I can combine 10 and 3. 10 and 3 gives me 13. So on the right side, I have 13, wrong color, 13 plus 2 root negative x squared minus 7x plus 30 equals 25. Now to get this radical by itself, I need to move 13 to the other side. So I subtract 13 from the right and subtract 13 from the left side. So that's going to give me 2 root negative x squared minus 7x plus 30 equals 12. Alright, I have those two hanging in front here. How about I divide both sides by 2 so that my equation looks easier to solve? So I divide the left side by 2, divide the right side by 2, and that gives me the square root of negative x squared minus 7x plus 30 equals 6. Okay, Now I have my radical nicely isolated. So by squaring this, that's going to eliminate the square root. Okay, so I square this side, the left side. I square the right side. And I'm left with negative x squared minus 7x plus 30 equals 36. Now how do I get x? I need to put this into a quadratic form, right? Set it equal to 0. So I can subtract 36 from both sides. Subtract 36. Subtract 36. And that gives me negative x squared minus 7x minus 6 equals 0. I like my first term to be positive, so I can multiply both sides of the equation by negative 1, or I can flip all the signs, okay? Flip the signs of the left and the right side, because I don't like this minus here. However, if you did it with a minus, you still get the same answer. So I'm going to multiply the left side by negative 1, just to flip the sign, and then the right side by negative 1 also. So it's going to become x squared plus 7x plus 6 equals 0. Alright, now let's solve this quadratic equation, this resulting quadratic equation using the x gain. So AC goes on top. AC is 6, B is 7. So what's the numbers times to give you 6 and not to give you 7? Let's try 1 times 1 and 6. So how about we go x squared plus 1x, because of this 1 right here, plus 1x, this 1 right here, plus 6x, this 6 right here, plus 6 equals 0. Break it down in center and factor by grouping, okay? Alright, so for the first two terms on the left side, if I can take out an x and work with x plus 1. On the right side, I'll take out a 6. I'll be left with x plus 1. And the factored form is going to be x plus 1 times x plus 6 equals 0. Okay? So there you go. Alright, so let's solve this. So to solve this, we set each quantity to 0. X plus 1 equals 0. And x plus 6 equals 0. And this one you subtract 1 from both sides, you have x equals negative 1. This one you subtract 6 from both sides, you have x equals negative 6. Alright? So the question is, are we done? Are we done solving the problem? Absolutely not. We need to check to see which results are extraneous. Either both are extraneous, which means no solution. One is extraneous, or none of them are extraneous. Okay, which means they're both good. Alright, so let's find out which one is the shoe, for example. Okay? Alright, so we're gonna do a check. Write this down, check. The original problem was so what the original problem was. Original problem is the square root of x plus 10 equals 5 minus the square root of 3 minus x. So let's test x equals negative 1. Test x equals negative 1. So we're going to have the square root of, is the square root of negative 1 plus 10, is it equal to 5 minus the square root of 3 minus negative 1? Is it? If I combine these two, is the square root of 9 equals 5 minus the square root of 4? Square root of 9 is 3. Is 3 equals 5 minus 2? Is 3 equal to 3? Absolutely. That means this answer, x equals negative 1, is good. It's a real answer. It's not extraneous. Alright, let's test x equals negative 6. The question is the square root of, plug in negative 6 for x, negative 6 plus 10, is it equal 5 minus the square root of 3 minus negative 6? Is it? Is the square root of 4 equals 5 minus the square root of, is the minus times minus is plus, so you can slash and dash, this becomes 9. Is this right? Is 2 equals 5 minus 3? Is 2 equal to 2? Absolutely. So this won't work. So guess what? Both of our answers are real. No shoes in this problem, right? So we have two real answers. So our answers are going to be x equals uh, uh, negative negative 1 and negative 1 and negative 6. Okay, so x equals negative 1 and negative 6. This is our solution set. All right, good. Now let's try one last example, pretty not too complicated, and then we're going to start on classwork for today. So example 4. Example 4 is as follows. Write this down. Problem 4. We have solve the square root of 4x plus 5 is less than or equal to 6. So let's solve this. So for this one, we want to get rid of a square root, right? So to get rid of a square root, we do the opposite. The opposite of square root is square. So all we do is we just square the left side and square the right side. So we have 4x plus 5 is less than or equal to 36. So to get x by itself, this is a single algebra problem right now. So we use minus 5, and then we'll have 4x is less than or equal to 36 minus 5 is 31. 4x is less than 31. And then we divide both sides by 4. So you're going to have x is less than or equal to 31 over 4. But when you have a less than problem, you have to have a bottom to this problem, okay? The bottom is as follows. You may not go lower than 0, so you also have to solve the problem. The radicand, this right here, the radicand, the stuff under the square root right here, that quantity must never go less than 0, or else you're not going to have a real answer because it's going to be imaginary because of that I. So this quantity has to be positive. So we also have to add the radicand. Also have to solve radicand greater than or equal to 0. So the radicand here is 4x plus 5 greater than or equal to 0. So let's solve that. Minus 5 from both sides. 4x is greater than or equal to negative 5. Divide both sides by 4. You're going to have x is greater than or equal to negative 5 over 4. So we're going to stitch these two answers together for a final answer. So our final result is negative 5 over 4 is the lower bound. Less than or equal to, remember it's pointing at it, x is less than or equal to 31 over 4. There goes our result. Okay? So that's that. You only do this part anytime you have less than, because you need a floor in order not to go into the negative world and have unreal solutions. All right, thanks for paying attention to this presentation. Remember, it's uploaded on YouTube for your viewing pleasure.